part 3. I got to finish this one. I got cut off. So we subtract 12 from 4 and get 8. Then bring the 6 down, and then we have 4x. So when we multiply, we get 8x squared plus 4x. When you subtract, you get 2x, and then bring down the 5. How do you get from 2x to 2x? A 1. So when you multiply, you get 2x plus 1, and you have a remainder of 4. So how you'd write that answer is 4x squared plus 4x plus 1 plus that 4 that still needs to be divided by 2x plus 1. All right, here it says Jack tells me that x minus 3 is a factor. He is incorrect but doesn't believe me. How could I prove to him that x minus 3 is not a factor? Well, you could use substitution. You could substitute 3 in, and you'd realize you wouldn't get 0, you'd get 16. So you'd say not 0, not a factor. You could use synthetic division by plugging 3 in, and you wouldn't get 0 as a remainder, not a factor. You could use long division, not a factor. You could graph it. It doesn't have an x-intercept at 3, not a factor. There's many ways to do this. You just need 2 ways. That's one way, and then you do another. So if you want to look on the answer sheet, I did 2. I plugged in 3, and I used 3, showing there's a remainder. So you can use more. This next one gives you this cubic, and they want you to divide. Now, you can't use synthetic because it's a quadratic. So we're going to use long division. So how do you get from x squared to x cubed? And x cubed, 6x squared, minus 7x. So those cancel. Negative 6x squared. Negative plus a 7 is negative 66x. So it doesn't feel right. Oh, 36. Why should I do that? I don't know. Okay, and then how do you get from x squared to negative 6? Minus 6, so negative 6x squared, negative 36, positive 42. I should have brought that one down. The remainder is 0. Okay, so if I break this up, it becomes this factor and this factor. So if I set this equal to 0, I have a 0 at 6. If I factor this, a positive 7 and a minus 1. So we have an x-intercept at negative 7, at 1, and at 6. So we'd have 6 here, 1 here, negative 7 here. It asked to completely sketch the graph. So when you sketch a graph, you really want to try and get intercepts, x and y intercepts. What's the end behavior? Well, since it's positive x cubed, we know one arm's going up. We know one arm's going down. It's going to look something like this. The most accurate way to sketch a graph is to actually plug in points. But there we go. It just said to sketch. It wasn't saying how specific. But since we're factoring and dividing, it's assuming that you'd want to use the intercepts. All right, find the value of k that makes the linear expression a factor of this polynomial. Well, if x minus 2 is a factor, then we know 2 is a solution. So 2, 1x cubed, 3x squared, negative 1, and k. You drop down 1, 2 times 1 is 2. Drop these down, 3 plus 2 is 5, 10, you get 9, 18. Well, if it is a factor, you would want 0 here. That means k would have to be negative 18. Okay? All right, and lastly, it says use U substitution. I don't like U substitution. It takes more time than just thinking about it logically. So when we have x squared, we'd say, do you have 3 terms with a plus in the back? And we would. So we'd say the sign appears twice like a Wendy's double stack. Minus, minus. When it's x squared, it's x and x. So when it's x to the 4th, it's x squared, x squared. 36. Factors are 9 and 4. So we just do what we did before. Then you said each piece equal to 0. So x squared equals 4. X squared equals 9. Therefore, x equals 3, x equals negative 3, x equals 2, x equals negative 2. 4 solutions. 1, 2, 3, 4. You're to the 4th power, so you should have 4 solutions, whether they're real or imaginary. And we say complex for imaginary numbers. Here, we do the same thing. However, let's trim the fat. There is an x that's a GCF. Well, we can do this now. Do you have 3 terms with a plus in the back? Yes. So this sign's going to appear twice. Factors of 8 that give you 9 are 8 and 1. So you're going to set each piece equal to 0 and solve. So we get 0. We will get 1 and negative 1. And we will get 2 root 2 and negative 2 root 2. So we have 1, 2, 3, 4, 5 solutions. Ding, ding, ding. You can always graph it in your graphing calculator and check your work. It should cross at these numbers. But what if you don't have a graphing calculator? It says it's 1901 and Sky does not have a graphing calculator. She needs to find all the zeros. Well, we know there's going to be 3. Say you didn't know how to factor this or it's unfactorable. Rene Descartes realized that you could look at these numbers and kind of hone in your search and figure out what a possible solution would be. And when you find one possible solution, you can chip away at this by using division to find the other possible solutions. So he called this the rational root theorem because it's only for rational numbers. So not like the square root of 8 or I, it'd just be for rational numbers or roots. And it was a theorem. Textbook companies started calling it the rational zero test for simplicity. I don't care which one you use. It says list all the possible rational roots. So he said if I take factors of positive and negative 12 and put them over factors of 1, I will hone my search to possibilities of numbers that we can use. So these are all numbers that are factors of 12 over 2 or over 1. So 12 might work, maybe not. Negative 12 might work, maybe not. So start with numbers that would possibly be. So I'm just going to cheat. I'll say I plug in 6. Oh, it doesn't work. It doesn't give me 0. Let's try plugging in 4. Well, we'll put 4 here. Does 4 work? I'll use synthetic division because it's the easiest. I'll drop 1. 1 times 4 is 4. 0. Negative 12. Okay. This is a remainder. This is a constant. This is an x. This is an x squared. So it worked. So that means 4 is a solution. Well, x squared plus 0x minus 3. This would be the remainder. Well, you'd set it equal to 0. So x would be the positive and negative square root of 3. So your answers would be 4, square root of 3, negative square root of 3. Okay? It says find all the zeros of this function. Well, there's no GCF. We can't use grouping because it won't work. It's not the difference of 2 cubes. It's not the difference of 2 squares. It's not the addition of 2 cubes. There's not 3 terms with a plus or minus at the back. What would we do? Well, we'd use the rational root theorem. So you take factors of 3 and put them over factors of 4. Or vice versa, sorry. So you could be 4 over 3, negative 4 over 3. Another factor of 3 is 1. Another factor of 4 is 2. Another factor of 4 is 1. So you could be 4 over 3, 2 over 3, 1 over 3. You could also be the negatives of those numbers. Other possibilities could also be 4 over 1, 4 over negative 4 over 1, 2 over 1, negative 2 over 1, 1 over 1, and negative 1 over 1. So what says the most likely to work? You would try a bunch, but I'm just going to tell you right now 2 works. Now, I did a shortcut to see which one worked. What could you do for a shortcut? I would just graph it in your graphing calculator and see where you cross the x-axis at. If I graph this, it's going to cross at 2. Now, it's not going to be easy to see where it crosses. If it's like square root of 5, you can't tell. Graphing really helps when it's a whole irrational number. So that's what I would use to get started. Now, once you have one solution, you can chip away at it and find the other solutions. So you drop 3. 2 times 3 is 6. 2 times 4 is negative 8. 2 times 2. So is it 2? Oh yeah, because this is negative 4. I messed up. Okay. So if you have a remainder of 0, ding, ding, ding. Constant x squared. 3x squared minus 4x plus 2. It has to find all the zeros. So you have 1 0. You use that too. Well, you can't factor, so I would use a quadratic formula, and when you do, you will get this. So if you want, separate them immediately. Makes it easier for you. And you'll get 2/3 plus or minus I root 8 over 6. Well, you know root 8 is 2 root 2. Now, that's fine if you want to leave it like this. Most of your professors want you to separate. Okay, so 1, 2, 3. All right, so that is it for your entire chapter review. You're going to be given an assessment just like this. Use your notes, use those homework quiz / checking for understandings, use this review. I prefer you to work by yourself. I'm not going to know if you worked with a classmate. So I don't mind you working with people. Just try your best to learn the content, because there are classmates in your grade that had me this year that are on pre-calc right now. And they're coming back to me and they're saying, Ms. Caserta, everything we learned in Algebra 2 is pre-calc. I'm doing so good because I had, Algebra 2 in the fall and I immediately went to pre-calc and it's the same. So if you skip this, if you just try to get through the chapter and memorize it and then dump it, you're going to get it again. So really try really hard. So work with people if you need to. I prefer you work on your own. But if you're working with people, work consciously and really try to understand the content. I'm really proud of you guys. You're not freaking out. You've been so polite. You've written the most beautiful things. And I really miss you guys. And I hope you're all doing well. And hopefully when all this is kind of caught up a little, we'll be in touch soon. Okay? Stay safe and good luck.